Okay, good morning, everyone. A couple of things to clear up from last week. Firstly, I just want to welcome Jen, who wasn't able to get here last week, but to say that from an earthing point of view, what we were concentrating on was the fundamental importance of earthing, but also how to use earthing in a dirty, polluted environment. And sometimes you have to take extra care and extra steps with earthing to avoid problems there, and to make the earthing work very well. So today's topic is about using Wi-Fi, or using broadband, sorry, without Wi-Fi. Now, with the questions I always get when I'm doing my surveys is, well, okay, you say we shouldn't be using Wi-Fi, and because I, for one, am extremely sensitive to Wi-Fi. And so the question is then, well, okay, but surely you need Wi-Fi to access the internet. And luckily, that's not true. You can connect it using cable. And the kind of cable you use is what we used to use years ago, which is called an Ethernet cable. It looks like that, quite flexible, and it's got there's this kind of terminal on the end. Should be familiar to most people because this is what we all used to use before Wi-Fi came. What this will give you is far more speed and far more security and reliability than Wi-Fi ever does. And it's not expensive either. So a wire like this, which is 2 meters long, is about between £5 and £10. But when you order them, it's really important that you specify the right quality. They come in different qualities called categories, or abbreviated to CAT. And so you need to have a cable where the shielding on it's shielded and it's earthed. And so don't get Cat 5, which is the cheapest one. It's what the default one. Go for Cat 5e or 6a or 7. So the slightly more expensive ones, but they will work better. And so let's have a look at when you get a broadband contract, the utility will provide you with one of these. This is a slightly old one, but simpler and smaller than the current ones. And this one was provided by BT. But the key thing is what it looks like in the back. So we have a power supply, which goes in there. It plugs your 5 volts or whatever it is to power the unit. And then we have a row of sockets here. And so from the supplier, you will have a terminal of some kind. And the same goes for whether you go for fiber or whether you go for copper. You have ultimately an Ethernet cable that comes out of the back of the terminating device, which is normally on the wall, and you then plug it in to the master socket there. Then, and then if you switch your Wi-Fi on, and plug this in, Wi-Fi is the default, and Wi-Fi will be transmitted all around your home. Now, there are ways of boosting the Wi-Fi around, and so be careful of those as well. If you buy, many houses have boosters, and particularly for televisions. Now, and you need to make sure that when you're doing without Wi-Fi, that you replace those units properly. So what do these sockets do? They're very easy to use. You just plug that in, and so that there is a latch on it, that little plastic latch, and that will allow you to do it. It's as simple as that. And now, at the other end of this cable, you can plug that into a computer, and you will have very fast, high-speed, very secure broadband connection, with or without Wi-Fi being radiated from this little box. So in order to switch, there are various ways of stopping Wi-Fi getting out. The first is to put it into a box or bag. We sell a modem bag on our website, which is really easy and effective. You just put it in that bag, pull the drawstring tight, and then you've got a much reduced signal, which helps an awful lot of people. It does leak a bit, and that's to do with the physics of how the radio transmissions work. And so you can, nearby to that, you'll still be able to pick up a Wi-Fi signal, and that's really useful when you've got people coming to visit, often grandchildren or whatever, who will not do without Wi-Fi, and they can still, if they're fairly near to that, they'll find it will still work. Obviously, that's not ideal. You've still got Wi-Fi in the area, and if you're very sensitive, then that's not good enough. And so what you need to do is log in. So normally there's a tag on the modem or something written on the back of it or underneath it, which will allow you to log your computer now connected to this through Ethernet, and then you can turn the Wi-Fi off in the software. So there's an address on the back of that, a so-called IP address. You type that in your browser, and you get straight into the computer user interface, which allows you to change all the settings on the modem. Now, BT and other manufacturers have, or other suppliers have, a general system where you can log in anywhere to other people with these modems. So airports or just walking along the street, you can log into a generalized system. And BT used to call that FON or FON, and they confusingly now call it BT Wi-Fi, which is a bit meaningless. And but you have to unsubscribe from that. And at various times, we've been able to log into your BT account and unsubscribe from it. But more often than not, you actually have to ring BT to their user support and say, please, can you unsubscribe me? And that goes for other companies as well. Now, so once that's unsubscribed and you go into the menu of the router, you can then switch Wi-Fi off, and it really does switch off. If you haven't unsubscribed, then you will, even if you select no Wi-Fi, it will still keep broadcasting. So what you have to do is to check it with a meter, something like this. There are various sorts. We're just about to, this isn't made anymore, and we're just about to sell a new one, which is called the Classic 2. And that's now available on our website, and I'll soon be producing a video on using it. So we've unsubscribed from the generalized service. We have logged into the modem's software as computer to a user interface, which allows us to change the settings and switch Wi-Fi off. And then we check that it has switched off with this kind of meter, which is a meter that looks at microwave radiation. So, and it's switched off. So for the simplest setups where you've just got one computer connected so that we've solved the problem. But normally there are devices that are a fairly long way from, or the next room or whatever, all over the house, which are currently connected to Wi-Fi. And you need to switch off the Wi-Fi transmitters in all those devices, most notably your computer. So once you've connected your computer, don't forget to go onto flight mode or actively switch your Wi-Fi off. That also is true for Bluetooth. Actually, many computers also have Bluetooth, and that should be off as well, and so that you get zero radiation here from your computer. So how do we get to the rest of the house then? Okay, so we use a device called a DLAN, D-L-A-N, and they're available from all the usual people, but certainly from many different kinds from Amazon. And you need to get the simplest one. You do not want one which is a Wi-Fi transmitter. And so it's the basic, you just find the cheapest one of their range. And okay, I've just had a note, I'm not quite sure what, from Gibbsy. Guy, can you please talk about power line adapters? So that's just what I'm introducing at the moment. So it's a very timely comment. Thanks for that. Anyway, so go and spend your £25 for a pair of these power line adapters when you're a supplier. So I would either use Amazon or RS. And they're really plug and play. So what you do is you get a small unit and of the DLAN, you plug that into an ordinary socket, and then you plug the other end of this cable coming out the back of that into that. And what that does then, it puts a broadband signal on all of your wiring in the house. And that means you can plug another DLAN socket anywhere else in the house and run an Ethernet cable from that. Now, I am particularly sensitive, and I am sensitive to those signals. So I can't use those, and some of you won't be able to. And that actually means running multiple cables around the house, probably getting an electrician to be able to drill holes and make it look neat. So that's just cables. And when you have cables, you want to multiplex it. So very often you'll have one cable going into a room, but you might have a printer and a computer and a laptop. So I've got Paul Blankley now. Hi, Paul. Feel free to use this chat room during this meeting. Okay. Yeah, okay. And
ignore that one guy. Yeah.
Okay, so you need say three. You've got one cable coming in. You've got three devices there. And so what you need is what's called a multiplexer or a switch. And each of these holes are called a port, an Ethernet port. And so you have a little box about the same size as this with any number of ports in it. You have one that goes in and all the rest go out. and it spreads the signal, repeats the signal from this one and splits it in all the different ways. And so again, so look for an Ethernet switch and for however many ports you want. And the minimum number is normally about 5, so it's 1 in and 4 out. And that allows you to drive, so you've got a home office and you've got your printer and a couple of computers or whatever, and it will service all of those. And that means that because of the signals that the power line adapters put on your wiring, you should probably put those on a timer so that you don't sleep in the house with those signals on. So ultimately, the purest and straightest signal, I'm lucky here, I'm in a flat and there's a big loft above and I can easily run the cables around. So I've got my whole flat wired up for direct Ethernet connection. It's really useful. So I use my TV as a smart TV. I don't use an aerial on the roof anymore. More signals to get rid of. Also, so if you do use a smart TV, you can get everything, all the channels you need on the internet. And so you can disconnect all your roof aerials, which don't help us electrosensitives at all, these roof aerials, and most particularly the amplifiers for the signal. And so particularly blocks of flats have one aerial, comes down to a multiplexing booster aerial, and they are very, very noisy indeed, and they put a lot of noise on every TV aerial connection coming down into each flat. I've seen a number of cases where there's really big problems with that. Again, earthing can help. If you can get your aerial properly earthed, that will kill a lot of the noise. So that's another advantage of having good internet etherneted around the place, so your TV can do without the aerial. So that's got multiplexers. So one extra problem that I've come across with the internet is the new generation of fiber. So you've got a glass fiber, which is a tiny, tiny little filament. It's not much thicker than a human hair, which, because it uses light rather than radio waves, is actually higher frequency. And you can get a lot more signal down the glass fiber than you can copper. And it will go longer without being boosted. So it's a very useful technology. But what it means at the end of the fiber, so there's two kinds of fiber. There's fiber to the cabinet, so the green BT cabinets by the roadside. It brings fiber from the exchange to there, and then you've got a device which normally is a couple of dozen domestic properties that comes off, and normally there's an awful lot of noise and a lot of dirty electricity caused by that on the copper that comes from that to your home. So in many instances, there's fiber to the cabinet as opposed to fiber to the premises, which is getting more common. But fiber to the cabinet can produce a lot of dirty electricity, and you need to get some expert help on how to sort that out. I've had a number of customers who've been made seriously ill, hospitalized in one case by this. And it was immediate. As soon as the thing was installed, I'm afraid the client was hospitalized. And if while he's at home, while that's on, his wife needs the internet to do her work, because she's a website designer. And as soon as that goes on, then he gets ill. He gets the symptoms again and has to leave the house. and we can filter that out, but it's not an easy job. And so if watch out for, if you upgrade, as a lot of people are having to do, to go to so I've got a message here from Nikki Shepherd, but I can't read it. Or here we are, meeting chat. Right. OpenReach have been up and down a pole outside my house last year. It seems that every time a neighbor upgrades to fiber, my symptoms go through the roof. And so, I mean, the signals are not going to change. So it's just your electrosensitivity, your own body immune system getting used to the extra load. Is that what it is? Basically, though, Nikki, it would be better if you could get a filter on your copper coming into your house. So presumably you're talking about fiber to the cabinet, and it will be why would they go up the pole? So they would be upgrading the copper bit to your neighbors, but they're adding your neighbor copper to the multiplexer in the fiber, in the cabinet that the fiber goes to. Yeah, so you need some filtration on your copper coming into your house to stop that happening each time. And yeah, yes, FTTC. How do you do that? Well, it's not exactly very straightforward. It does vary quite a bit, and I'm afraid so it means I need to come along and take some measurements with my dirty electricity oscilloscope, which runs on my laptop, and I plug it all in, and we can see what frequencies are involved and specify a suitable filter for that. And we're sort of just getting used to it. I mean, there may be before long, I've just found a common solution, but at the moment I'm doing it one at a time and working with those. But it is quite a problem, and many more people are getting sensitive to it. And I'm afraid, well, obviously, taking Wi-Fi away from your house obviously is a major improvement for every electrosensitive, but you're still getting this noise coming in to your wiring from this thing, and it can come back through the power supply into your mains, and then it makes it even more important so that you set up your workstation so that you are not being fed dirty electricity into your body through your keyboard and your mouse, and that's ultimately what you need to do. And again, this is where earthing comes in. So you need to earth the computer. There's an earthing lead which we sell on our website. It couldn't be simpler. It's just a connection to the computer chassis, the outside connection of a USB, an old USB-A thing to the earthing, to the electrical earth of your house. And as often as not, desktop computers and laptops, voltage just floats and it's not strapped down to earth. So if you get the insides of your keyboard, the inside of your mouse down earthed, and you are earthed because your feet, as I am now, my feet are on an earthed cable, or you can put it on a seat, like Jen's car earthing seat, pad you sit on. The advantage of the sit-on one is that in winter, where you might be wearing shoes, that still keeps you earthed, but you've got the annoyance of a lead coming up to your chair all the time, and that tends to come undone. So I go for a an earthing mat to put under your feet, and that earths your body. And that means when you put your hands on the keyboard, that there is no voltage difference because they're both earthed, and they're not charged in any way. And so and so there's no electric field or voltage between your hand and the keyboard. And that's the key thing to stop, because it's one of the major mechanisms for dirty electricity to affect us. So, right, we've got, so it's past now. And so all I'd like to, so I've got questions here. It's great the chat here. So I've got number 824535982769 to everyone. So OpenReach are planning on eliminating all copper wires by 2025. Does that mean we will be forced into using wireless, or we solely use Ethernet? Well, just to be absolutely clear, it's sort of splitting hairs, but they're still keeping a lot of copper. For instance, my village here, they're going to keep, as far as BT are concerned, and there's another company come in that's just going to do all the fiber. So as long as BT is still providing voice, there will still be copper around, but that copper will become far more polluted with dirty electricity from these fiber multiplexers. But the question from the audience is, does this mean we'll be forced into using wireless, or will we still be able to use Ethernet? Well, there's nothing stopping us using Ethernet in our own home. We will be provided with or we will have some kind of modem or router, and we just plug our equipment in our house into that router, and we make sure that router is not radiating Wi-Fi. The other major source of Wi-Fi, like signals, which are really very, very intolerable for electrosensitives like me, are smart meters. For goodness sake, do all you can to avoid getting a smart meter, because they do a Wi-Fi like signal for inside the house, which is a sort of Internet of Things called Zigbee normally, to talk to the display unit that's connected inside the house. But also they have a particularly nasty signal, which is nothing, 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 nothing for 15 seconds, and nothing, 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 nothing. So just when your body's calmed down a bit, kind of in the, oh, my goodness, and your poor old immune system is triggered again. And they're really very, very difficult to cope with. Very low average power from the waves, so-called flux density. Very low power from the waves on average, because it's a very, very short signal, so it's every 15 seconds. And so you need to take measures to shield from that. And it's really difficult for people who live in flats who might have got any number of them in their hall, and it's radiated. They radiate 360 degrees, and so you need to shield the wall, the relevant wall, to try and stop those signals coming in. But they do reflect off anything metallic, so it still leaks in, and because it's such a short peak, it is difficult to get rid of. Right, so a suitable filter. Dirty electricity covers a wide spread of unwanted frequencies. Our body has many bioelectrical or bioelectronic systems within it, which can all act as resonators or little aerials, which then are tuned into, just like a transistor radio, are tuned into particular frequencies to resonate. I know if anyone been in an old car, an old Morris Minor or something, that's got a biro in the pocket, and then at certain revs, it will buzz. The biro will buzz, and as you go through the revs on the engine, accelerating through the gears, and as indeed the exhaust system on a Morris Minor has got a particular resonance that isn't designed out. And really, what we're going to have to do is to go through what the car industry had to with their exhausts, where they were going, loudly resonating, or certain motorbikes now. We just need to silence that with filters. And so there's a lot of equipment out there that's generating all these signals. And there is an unfortunate thing about the physics or electronics of things, that if you put a microphone to a flute in the orchestra, you will have a beautiful, smooth, pure, what's called sine wave, and that's the purest sound, or the purest thing. And the sound analogy, or voice or music analogy, goes across to electronics. Very similar kind of maths and physics, except one is electricity, or the flow of electrons, and the other is pressure waves in the air. But if you put then a clarinet to a microphone, you don't get a nice smooth single frequency. You get a square wave. This is on, noise, 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 and then it goes down, and then up, and then down, and then down. So you get what's called a square wave. And inherent in that, to build a square wave, and that is done just physically in electronics by not having a worn out battery in your transistor radio. It starts distorting because there's not enough force to drive a nice full smooth wave. It goes up so far and then cuts off, and then goes down so far and cuts off. So you get something beginning to be a square wave. And when that happens, it generates all these interference frequencies going right up. And there's so many frequencies involved. One of them's going to get you. Everyone's different. You're going to have different resonant frequencies, but similar. And if you've got all those frequencies there, you're setting yourself up for your bioelectricity to resonate with, like the biro and the Morris Minor, to resonate at one or more of those. And the idea is to have an electronic filter at the relevant, at the source, hopefully, of relevant things. So there is different ways of dealing with this. And so we've, to deal with laptop noise, there's two ends of it. One is so it's quite easy to see where the electronic noise can come from with a laptop, because the power supply is conveniently there for you to see. There's a plug, there's a thicker wire, which runs at 230 volts, into a little black box. And then there's a thinner wire, which runs at 20 volts, direct, supposedly direct current, ideally direct current into your laptop to charge the battery. Now, those little black boxes are incredibly noisy. They're like a motorbike without an exhaust, and it's kind of can be very upsetting. And what they do, this not only puts noise towards your laptop, but the main noise actually goes out into your electricity. So what you need is a plug-in filter. It's a very simple device, a little black box that you plug in next to it on the wall, and it soaks up that a lot of the biologically active frequencies, and does often a very great job in that particular that particular situation. They were marketed for years as Stetzer filters, and there are a number of other alternatives now. They're very, very simple devices, and in the right circumstances, they work really well. But now we have a situation where people are producing their own electricity. So instead of just being small consuming devices of electricity, like laptops or whatever, we've got things that are industrial power strength. So whereas the strongest thing that you can plug in to the mains is a kettle or an immersion heater. They're the maximum at the moment. Well, also some electric cookers have got extra thick wires to them, but on ordinary wiring, you've got 13 amp maximum. And whereas even a fairly ordinary solar panel system is 30 amps. And you take power off the roof. So you've got the solar panels on the roof, and they produce direct current, and they're connected all together like Christmas lights. So they can produce up to 600 volts. And so there's quite a big box called an inverter, which changes the direct current off the roof into alternating current. So you can get your money back and actually use the power. But these inverters are a very, very wild approximation from this. Really, this is a Harley Davidson without an exhaust, or perhaps a normal Harley Davidson exhaust, when they're so noisy. And what have you got? You've not got. You should be producing what's called a pure sine wave. But what they in fact do is they normally work at about 20 kilohertz, so 20,000 times a second instead of 50. And so there are 20 times 20 is 400. The frequency they work up is 400 times too fast. And so they go there, and then it's got a switch on it, which it goes from plus to minus, plus to minus. So you've got something a bit like a square wave, except that it's it's got 40 pulses instead of one pulse each time, switched at 50 hertz. And so it's a very, very rough approximation to what it should be. And you can get pure sine wave inverters for small, for your caravan, for your log cabin or whatever, but not for an ordinary domestic house. They just don't make them. And you can get them for workshops too, larger industrial ones, but they're extremely expensive. And so we do a full range of filters, including filters for solar panel inverters. And some people, and we've had people, they switched on and people have to run out the house. Electricians have to run out the house in order to stop getting horrible symptoms. And yet it's still very easy to install and work extremely well, I'm pleased to say. I've got a water smart meter, and the reason is that they're battery powered, and they're driven by a turbine in the water. So as you consume water, it drives a little fan, little generator, which powers the battery, which then powers the radio to give a signal. And they work in a way that there's a man in a van outside. He sends a signal to the water meter, and it's supposed to reply back with its reading. So only very, very occasionally does any signal come out of it. Whereas in contrast to a electricity reading smart meters every 15 seconds. So that's why I thought, oh, doesn't matter. I'll try it anyway and see how it works. And it's so hopeless because I don't use enough water to keep the battery charged. So when the man in the van drives past, he has to come and knock on the door and climb into my roof and read the meter. And of course, it was put in the roof so that it would transmit. And whereas before the meter would have been downstairs and much easier and quicker to read. So it's a complete farce. It's just not thought through at all. But basically, the water smart meters, in my experience, they might change the technology and become horrible, but it doesn't seem to be a problem at all. So there's one less thing to worry about, but you really got to worry about the smart meters that measure electricity. They are a problem. They're a real problem for me in everyday life. Luckily, the rest of the people in my block of flats have chosen not to have them. I've told my Ecotricity, my supplier, that if they even ask to put a smart meter again, I will change. And they've stopped sending me letters now. I will change supplier. That's the only thing they listen to. You say you're going to change supplier. They don't want to lose their customers. And they can, if you really can't stop them putting one in, it's all one's already in, you move somewhere, there's one already in. What they can do remotely is that they can switch off the transmitter. Again, you have to check they switch the transmitter off, and you need one of these to check it, to make sure that they have switched it off. So if you go to your electricity cupboard, probably maybe shared with, there might be in a block of flats, there's going to be multiple meters there, and it's incredibly easy. It's so you just count 1,000, 2,000, 3,000, 4,000 up to 15,000, and then there's a and then there's a afterwards. So the is for is to get back to the utility using 2G or 3G phone technology. And then there's, which is Internet of Things, Zigbee or whatever, to connect to your reader in your kitchen. And they can switch that off remotely. It does mean you have to do the readings yourself, but yeah, and that seems to work okay. But you need to check regularly to make sure they haven't switched it back on again, because these devices, because of security and bugs and things like that, they upgrade the software every so often. And when they upgrade the software, it can change the settings back to default, which is radiation, radio connection. Excuse me, radio connection on. So they will quote Public Health England, and Public Health England are one of these agencies that are supposed to protect us that have been completely taken over by the industry. If my electricity and gas smart meter is outside, am I still in danger of pollution? Yeah, unfortunately you are, yes. Yeah, because unless you happen to have insulation in your wall that's got an aluminium layer on it to reflect the microwaves, it will just go straight through the wall. And they're designed to do that because in certain circumstances, the old-fashioned setup is your meter's under the stairs and in the middle of the house, and it needs to go through all the walls to actually get out. I live about 400 meters from a fire station, which has an aerial on the roof high up. There is line of sight from there to my bedroom. Should I be concerned? Tricky one. Depends how sensitive you are. Depends how careful you want to be. But there are a lot of studies to show that anything nearer than at least 500 meters, you are at risk of increased risk of cancer, and a load of other symptoms too, tiredness and brain fog and whatever else, when you're that close. What you can do, you won't be able to get that changed. And in fact, in America, the lady is a really good website by somebody called Magda Havas, Magda-Havas. Look it up. She's a Canadian. She's retired recently. Canadian university professor who's done a load of work, including working on dirty electricity, actually, but as her main subject. But she's also worked with the US Fire Brigade Union, and what they've done is to stop. There are special rules for 5G transmitters, and the only people who are protected from them in the nation are firemen, because of her working with the union. But so it's an important test case. Once you have a smart meter, can you revert to the old system? With difficulty. You sometimes can persuade them that you can buy one. You can buy an old-fashioned one and pay for it to be installed yourself. Okay, so any other questions, anyone? Just the last go. Okay.
I've actually allowed everyone to unmute themselves if they have a live question they'd like to ask at the moment.
Yeah, I'd like to cover anything previous, other that they haven't understood, what was particularly important, and also I'd like to know what to do, a subject for the next few, or ideas for the next one. I mean, dirty electricity has really come up today, and I'd like to go into that a bit deeper because it's such an important subject, and also rather misunderstood. So what about using kitchen tin foil to reflect EMF waves, for example? Yeah, it will do. It'll do it very well. It's not actually the metal tin; it's the metal aluminium, and from a technical point of view, it works really well. But from a sort of ordinary DIY point of view, it's a nightmare because it just tears all the time. You try and stick it up on the wall, and it just tears. So we sell a wallpaper called ISOFOL, ISOFOL, which is specially made for this purpose. But the problem with that is that many buildings trap moisture, and something that's really serious for electrosensitives is mold. And if you excuse me, if you trap the mold behind the aluminium is what's called a vapor barrier, so that if your wall is drying out after a heavy rainstorm or whatever, it can't, and that means you end up getting condensation in there and mold. And that can be really triggering for electrosensitives. And Dr. Klinghardt, who's an expert in this field, has done the research and has found that mold has got poisons in it called mycotoxins, and that under microwave radiation, I think he said it can increase the production of mycotoxins by a factor of 800. Good old microwaves again, causing us great problems. So the wallpaper that we sell, which is basically tin foil, it's basically kitchen foil, but it's paperback so that you can handle it and glue it without it tearing, and cut it nice and easily and all that kind of stuff. Has got perforations. So every 3 millimeters, it's got a 0.2 millimeter hole in it to let the vapor through. So that's yeah. So maybe an effective solution would be to glue aluminium foil to a sheet of card and place it against the wall. Well, yes, actually, why not? Or even, you know, lining paper. But you need to get a pin out, and you need to pin lots of holes in it. And also, there's the case that if you're shielding a particular radio wavelength, then you need to make sure that any gaps in it are a good deal smaller than the wavelength of the radio waves. So when we're talking about microwaves, it means that you must not have any centimeter gaps at all in your shielding. So that means the wall in front of me has got two windows in it. So all the woodwork needs to be painted with shielding paint. There are lots of different types. And more recently, more convenient is powder. You mix up the powder and you paint that, the carbon powder. And so, and there are different versions of it too, depending on your particular requirements. So you need to choose which paint it is. So all the woodwork, the window frames, the glazing bars, the windowsill, all that kind of stuff, and the architrave, all painted, and that will stop the radiation coming through the wooden bits. Now, the walls then should be papered, and I recommend 2 layers of paper. One, the aluminium isofol that we got specially made in Switzerland, and also then a layer of absorbing wallpaper, because if you have a room with reflective surfaces all around it, it means that you'll always get some leakage of radio waves coming in. And if you've got, mirrors facing each other, you'll get multiple internal reflection, and you will get special effects. You'll get hotspots, and you'll get reverberation, resonance, and that kind of thing. And so that makes people very uncomfortable. To stop that happening, so I've been several cases where people have worked really hard to get rid of microwave radiation coming in, but then it felt uncomfortable in there. But when we put our absorbing wallpaper up, which absorbed these reverberations, the absorbing wallpaper is not as effective as the aluminium at reflecting it all away. So you get the base layer of aluminium reflects all the microwaves away, and so does the paint. But then to stop multiple internal reflection reverberation, then we recommend the absorbing wallpaper. So yeah, and once you've done that, you can minimize the gaps. If so often people just put a board up and say, "Oh, that would be good enough." Well, unfortunately, it isn't. The microwaves just come past, and they what's called diffract, so that it comes through a beam, and then they spread out. So you've got to be really careful on how you design all of this. And it is better if you could do something on the floor as well. So normally when there's a complete refurbishment going on, you can then specify to the builders and the architect exactly what's got to be done on each surface, under the floor, on each wall, on the doors and the windows and the ceiling. Okay. So Patricia, to everyone, what about the windows? Well, very good point, of course. Some modern windows, so if you look at the electromagnetic spectrum and go through all the different frequencies as they increase, you have heat radiation, or what's called infrared or below red, and then you've got the visible spectrum, which red right up to blue. And then you've got more than blue or ultraviolet, which is even shorter wavelength. And then that becomes ionizing and particularly damaging. But if you go the other way, so below infrared, below heat radiation, you begin to get into radio waves. So right at the top end of radio waves, you've got radar and so on. And the top end, some things they're talking about in 5G are really at the top end there. So when they're treating lots of modern glass windows have got metallic things sprayed on them, which stop the heat radiation. They reflect the heat radiation. So in the winter, when you're warm inside, it reflects back the heat into you and is far more thermally efficient. And in the summertime, it reflects the strongest heat from the outside coming in. So it's much better glass to have that infrared. And sometimes the infrared protection extends a bit lower and begins to go into microwave. And so you can get some microwave, what's called reduction, or what's called attenuation. You can get from the coatings on the glass. And sometimes that happens. But it's unusual. And so most of the glass just lets the microwave radiation in with no attenuation. And actually, incidentally, so do yellow bricks or the non-red coloured bricks. Red coloured bricks have got iron in them, and they do reduce the radiation coming in. But pale yellow, grey London bricks have got no iron in them, and they just let it straight through. Now, which is unfortunate. Anyway, so you need something on the glass to actually, which has got coatings on it, which will reflect microwaves back. And the strongest plastic you can get to do that is something called mylar. It's what car headlights are made of these days. So it'll survive as, if it'll survive a stone city hitting the headlight, it's pretty tough stuff to stick on your glass. It's the same stuff. A lot of cars now are specified with blacked out rear windows, and it's the same. It hasn't got the black color in it, but it's got microwave reflecting components in it. The cheaper ones are actually green colored, and they reduce the everyday visible light coming in. But the more expensive ones don't do that, and you lose about 20%. But they're not cheap. And they're really easy to put up. Anyone who can install those films in the back of cars can install this. You do it you do it wet. You spray water on it, and with a squeegee, and you put it, and then you trim it with a scalpel. It's very quick and easy to do, but you need to be manually skilled to do that. Otherwise, you just get loads of bubbles, and it's not cut very nice, and it's expensive stuff. So. Get somebody who knows what they're doing to do it. So just to recap, yes, you can put up boards and all that kind of stuff, but the gaps are so big that it won't really stop the microwaves coming in hardly at all. And and the difference, so you measure attenuation in factors of 10. So you go down to, misleading websites say it cuts out 99% of the radiation. Well, actually, that's not terribly good. You really want, so that the aluminium foil cuts it down to more than 1/1,000,000th. Okay, so that's the kind of thing you're looking for. But when you do that, the smallest gaps let through, and the factor of reduction changed from 1/1,000,000th to something like 1 in 10 or 1 in 100, which is, it's a help, but it's not nearly as good as it could be if you really want to make a properly effective job. anyway, so look at, so these things, these factors, these shielding factors are called dB ratings, and for every, or when you're talking about power, of the power of the radiation still coming through, you have a dB rating, and so that 10 dB is a factor of 10, 20 dB is a factor of 100, 30 dB is a factor of 1,000, and 60 dB is a factor of 1,000,000. And it's worth paying attention to all the gaps to get it really nice and low, particularly if you've got a mast close to you, as the audience member who has got the fire station 400 meters away. Can you just very quickly repeat about unsubscribing from BT Ray router? So you ring them up. You have to have your bill with you so they know what your account number is, and you ring them up and say, "I'm okay, you know, this is your subscriber." This is what they call them, and to their help desk, and say, "I wish to unsubscribe from BT Wi-Fi, the general service." You might be able to do it online. I haven't checked recently. You might be able to just log into your own customer account and request it there. But you know, we'll try that first, and then wait in the queue until they bother to answer. Okay, so we're up for time now. Thank you for all your interest and the great searching questions that you have for us. And so does Y-Shield encourage mold? No, it doesn't. It allows moisture to flow through it. And there's some other interesting products that I've not tried. There's one new German product, which is basically you mix powder in. Right, well, so what I'd like to cover next week in a bit more detail is dirty electricity. And I can show you how to deal with it. There are a lot of new situations with heat pumps and other new kind of things. So the new washing machines are a real problem, and they need thinking about. There are various things you can do, and one of which is to fit a filter, but it needs to be a specialist filter for that particular application, and not just the little basic ones. Okay, well, thank you all very much. It's been a great pleasure for me to do this. Watch out, we'll send an email on the distribution list, and thank you all for attending. Hope you found it useful.
Thank you, everyone.